Okay, let's take a look at the circuit here. We have this AC circuit. We got a voltage supply, and we got a couple of elements, resistor, RLC essentially, a circuit. And we're told we want to find voltage as a function of time in the circuit, so we want to figure out what V0 is. So to illustrate using phasors and phasor domain or frequency domain, we want to convert this circuit into this circuit down here to help simplify our analysis. So let's go ahead and write this down. So our voltage source is 20 cosine 4t minus 15 degrees, and then if we're gonna go from time domain, so we're going from time domain to frequency domain or phasor domain. I'm just gonna say frequency. We know that Vs is equal to, we take the amplitude 20, put that up here, and then the angle is going to be minus 15, minus 15, and this is going to be in volts. The omega, or frequency, we'll just put on the side. We'll use that later on, so we'll just say our omega is equal to 4. Okay, so we got our omega here, we got our angle here, and then we got our 20 here. So that's how we take the voltage source and we put it in phasor domain. Yeah. The other thing we know is that we have a resistor, we have a capacitor. The resistor is going to stay the same, so it's just going to be 60 ohms. However, the capacitor, 10 millifarads, is going to be converted using the equation we've discussed before. So it's 10 millifarad. If we're going to go to the frequency domain, it's just going to be 1 over j omega c. So we can just plug that in here. 1 over j omega is going to be 4, and c is 0.010. Okay. We do the math, flip the j, and then we get minus j 25 ohms. Okay, so that's our capacitor there. Next, we want to do the inductor, which is our 5 Henry. So the 5 Henry inductor, it's just going to be j omega L. Okay. Again, our omega is 4. L here is 5. So we have j 20 ohms. So we've determined our voltage source in the frequency or phasor domain, our capacitor, as well as our inductor. And that's how we get this new circuit. So this new circuit is essentially this guy, and the voltage source. That's how we get those values. And of course our V0 is going to be in phasor domain as well. The resistor stays the same. So now what I'm going to do here is I'm going to take my resistor, and I'm going to call this my Z1, and then the parallel combination between the inductor as well as the capacitor I'm going to call Z2. So Z1 is just 60 ohms. Z2 is going to be minus J25 in parallel with J20, which if we rewrite it, it's just minus J25 times J20 over minus J25 plus J20. We do the math there, it's going to give us J100 ohms. So now we have Z1 and Z2. I'll highlight that. So we got Z1 and we have Z2 right there. Now, to determine V naught, we can use our voltage division rule. So we can say voltage division. And what that's going to give us is going to give us V naught is equal to Z2 over Z1 plus Z2 times our voltage source. And all of those are known, so it's just a matter of plugging them in. So we got J100 over 60 plus Z2, we said was J100, and then our voltage source was 20 at an angle of minus 15 degrees. Again, you have the choice here to put them all in rectangular format or put them all in polar format. There's a bunch of steps in here. I'll let you pause the video and work that out on your own to confirm how to do that. But as I mentioned in the previous example, you have two different methods to keep it in rectangular format or put it in polar format and do the math that way. Again, either one is fine, but if you do that, you get 0.8575. Let me delete that. At an angle of 30.96 degrees times 20 at an angle of minus 15 degrees. Again, so your choice of how you're going to approach this depends on how you do this guy. Okay, and then we do that there, the math, 17.15, and then this is going to be 15.96 degrees, and this is in volts, and this is what our V naught is. So let's go ahead and highlight that. Okay, now we just need to convert it back to time domain. And to do that, V naught of t is equal to 17.15 cosine, our omega was 4, so 4t, and our angle here is plus 15.96 degrees, and this is in volts, and this is what our voltage is, and that's our final answer in time domain. Let's scroll up. So this was our circuit, and this is how we determine V of t in the circuit.